The following presentation has a title, VTS Getting Started with 3D Map Application Development. And
Ta-da, great. Hello. So there we go. I'm Ladislav from Melon Technologies, and I'm going to tell you something short about how to get started with 3D map application development. We have seen what options, what you can create with VTS. I'm going to show you how to do it, more specifically how to write a simple JavaScript application in a browser. I'm not sure if I see new faces, but I'll give you a short rundown of what we do as a company. The Melon Technologies is a software development company in 3D mapping business. Basically, we have two projects. First is our in-house computer vision and deep learning driven reality capture pipeline. Basically, we take aerial images and we extract 3D models from them, and we extract some semantic information from the 3D models. The second part of what we do is the open source VTS 3D geospatial stack, which takes outputs of our first step, fuses them with other 3D sources, DEMs, DSMs, orthophotos, adds and streams them to various clients across desktop, mobile, or web. The applications are straightforward: virtual reality, artificial reality, augmented reality, interactive simulations, gaming, and geospatial like 3D mapping. What we are going to talk about is we'll see how VTS is a kind of alternative approach to 3D mapping, what are its components and concepts, and I'll show you how you can create your first JavaScript 3D application. So why we say VTS is an alternative approach to 3D mapping. Maybe if you heard or if you do something in 3D, you certainly know that there is open source client Cesium.js, that there are open source Google Maps Enterprise, and so on. So a natural question would be, who needs another 3D map browser? Because there are lots of them, or at least two of them that work quite good. So why should you need it? So let me quick stop and try to kind of destroy this question. So first, VTS is not just a browser. It actually it's a whole integrated system. It consists of streaming servers, data management tool suite, and clients. And it features tight client-server integration, which basically means that if something can be done on server or doesn't make sense to do it on client, we usually do it on server to allow the load on the client. So it's a more integrated system than just the browser. And it's not just an integrated system for map streaming. It's meant for generic geospatial applications, like we said, augmented reality, virtual reality, and gaming. So we call it more integrated system for virtual landscape streaming. And one last thing, we certainly think it's not another 3D browser, because the development started pretty early, actually in 2013. It's already a second generation of the technology, so we went through some, I would say, maybe in some sense dead ends or whatever. So it's kind of really mature technology. It was designed to directly compete with Google Maps in Czechia. It actually succeeded. You will hear more about it in our tomorrow's VHR imagery talk. And so in this sense, we are one of companies that actually pioneer streaming 3D content. So yeah, the technology is pretty mature. So if I reformulate the original question, like who needs mature integrated system for virtual landscape streaming and rendering, our answer should be, of course, everyone, because we do it, we use it, or at least everyone who works with lots of 3D data, because that's what we do. To summarize VTS strong points, it's data scalability. You can work and fuse together terabytes of 3D and 2.5D data and stay sane still. There are high-performance streaming servers for static data streaming, and also we have bandwidth-optimized dynamic TIN and orthophoto generation. and they are lightweight and fast clients for web, desktop, various operation systems, and Unity. A tagline can be the more data you have, the more VTS shines. So what are the key concepts and components of VTS? We have the streaming servers. First, it's a map proxy, or VTS map proxy. It's not that map proxy, you may know. It dynamically converts non-VTS resources to surfaces, bound layers, and free layers. Bound layers are basically textures that are draped over the surfaces. And can be thought of as a powerful spatial reference system transforming tile map service server. Basically, you can just supply it with raster DEM and will spit out on demand mesh tiles that browser can render. The second server is VTSD, aka VTS daemon, which streams static data and products of data fusion that are also static and that are stored in VTS storage. And it also serves map-config.json, which is entry point for our JavaScript application we are going to talk about, and for all the clients for the sake of it. The map-config.json contains basic metadata that tell the client where the resources are, or where it is in the world, and so on. So all the basic information it needs to render the scene. Then we have data management tool suite in VTS. Most important is the VTS tool. It's a kind of universal tool for managing VTS storage. It takes care of data fusion. It removes data from storage. It's used to add the data to storage, which is the time when the data fusion is performed. And there are a suite of helper tools usually for pre-processing the resources for map proxy to allow the map proxy to dynamically stream them. And of course, we have VTS clients. There is a JavaScript WebGL-based client for web, C++-based clients for desktop for all major systems. And we have also this game engine plugin. So if you happen to develop games, you can try to develop them based on some real data or real maps. So now to your first JavaScript application. So first, what you'll actually need to create the app. You need two things. You need the browser itself. You can either stream it or just download it from our CDN. You can clone it from GitHub. You can add it to your project using NPM if you develop in Node.js. Or you can just download from GitHub pre-built or minified library, host it on your own. Then we need the map configuration, the map config.json. As I said, the file that contains the basic metadata. Here you can, again, go to our web or to JS examples that are on GitHub in the browser section. Or you can install your full-fledged VTS backend instance using a single Debian package as you've seen in previous talk, and run it like on your own, all on your own. The app is like very basic. Yeah, you need HTML and JavaScript. The HTML looks like this. We basically just load the browser, load our JavaScript of our application, and we create one large div that contains across the whole page that contains the map. The JavaScript is even simpler for this case. Once the div is loaded, we call the function startDemo where we initialize our browser with the map configuration we obtained somewhere. So how this looks like. The map configuration actually contains the global DEM, local DEM, some orthophoto, 2 3D models, and 2 layers with cadastral data. So you can see somewhere, maybe, you definitely see the vector cadastral layer, you can see pieces of raster cadastral layer, and it looks like kind of a mess because we displayed it all together. So we want to do it in some more orderly fashion. So first we will hide the cadastral layers to see just the 3D, and then we will display them in some orderly fashion. So To hide the layers, we actually just add some other parameters when constructing the VTS browser. One of them, there are many of them, they are all documented on GitHub, but one of them drives what we see in the browser, and it's called view, and it has like its object. It has few members like surfaces and free layers. Basically, here we tell what we want to display, and here we want to have our two DEMs. One is global DEM based on GTOPO 30, and we have some local finer DEM of Czech Republic. We want our two 3D static models, like the model of whole village and model of the center. And here we, and here we want to hide our vector and raster cadastre because it's free layer. And also we want to drape blue marble imagery over the global DEM, so we have nice globe. And we want some high resolution orthophoto over our local DEM. So that's done here, and that's why bound layers are bound, because they are actually like bound to the particular surface. So yeah, you may notice like I'm saying some like, or you see some like symbolic names. All those are actually defined in the map configuration you fetched, and this kind of expects that you know what you are working with, of course. If you produce your map config using your own data on your own VTS backend, you will of course know what the names are and how to handle them. So how the result looks like. We have hidden the vectors, so now we see only 3D. It's much less messy, and but yeah, we want the vectors there, just in orderly fashion. So we will create some control that will allow us to turn the vectors on and off. So how to do it? We will add some snippet to our JavaScript. Basically, we use the browser API, the UI component that, again, it's something that's documented on GitHub. There are many live examples. You can go through them. If you need to do something particular, it's best to just find it there and like piggyback on the live example. The browser UI takes care of many things like event propagation, so the clicks will get propagated well and so on. So it's good just to use it and to try it on your own. And we add a HTML snippet of control element with 3 radio buttons, like we don't want to display any cadastral data, vector, or raster cadastre. We store the handles and we register on onChange callback for the whole form. And in onChange callback, we query the current view, which so we know like what's displayed currently. And based on which radio button is checked, we either hide our free layers, we display the vector cadastre or the raster cadastre. When we modify the view in this way, we update the view. Also, we need a style for the control element, which is just some CSS style. It's in HTML file. How does it look? So we have this little control. We can check if we want to see the raster, so the raster will show up. You can just browse around, see how it looks. Of course, the raster has a downside that the numbers actually won't turn because everything is rendered in raster. Or we display the vectors, which are nice and styled. So this is about it. Yeah, and you may wonder, we have like two 3D models there. So we actually may do the exactly same thing with the 3D models. So I'll not go into the code because I think you have already enough of it. But I'll show just the result. Basically, we edit second control in very much the same fashion as the first one. It's just with checkboxes, the similar onChange function, and we just query the state of the queries the state of the checkboxes. You can see it's seamlessly fused. You can turn on and off various layers on the client. So the resources through fused, they are handled independently on the client. So yeah, that's about it. You can turn like any of them on and off, and it still looks quite good. So I think that's about it. Yeah, I'll show you a quick live demo if I have still a minute or two. So let's see. Yeah. If you happen to be in St. Louis, to Phosphor G North America, so we actually created some nice model of St. Louis. And so here, you can't see this control. Okay, so here's the same thing basically. We have the vector data. We don't have the raster data because City of St. Louis has only the vector data. So we can render the building parcels. If you remember, the conference was in this hotel, I think. And in addition to vector data, we can actually, this is done like on the client, it's not fused on the server. So this is like what other things you can do on the client. You can actually embed like your model, like OBJ mesh model from whatever source. And here is the example of the lot 2 extracted buildings. So this can be just done on the client. And it's like fused, the whole globe it's like global map. So that's about it for me.
Okay, thank you very much. Applause. Question? Yes?
Do you rely on some 3D tiles technology to render or to serve the data in a more fluid way?
Yeah, so the question was if we rely on 3D tiles?
Yes.
Yeah. Well, basically, not so far, but as VTS is open source, we have like pretty straightforward way to write converters from other formats. Currently, we support 3D only, like the conversion on the backend. So, for example, you can import, if you know S3 scene layer package, like encapsulated I3S or SLPK or lot3, but it's possible to also write an encoder or converter for 3D tiles. But so far, we don't work with 3D tiles on the front end.
Okay, thank you. Another one? Yes?
You said that we can use DTM and also some of the photo to make the 3D. But I didn't understand in which format the DTM should be.
Yes, the question was that we can use the DTM and orthophoto, and which is the like required format of DTM. So basically, we work. The map proxy works with GDAL readable rasters. So basically, if you have GeoTIFF, the DEM in GeoTIFF, the orthophoto in GeoTIFF, but also in like WMTS, WMS, you can work with all of them. You basically just do some very basic pre-processing of that, but it still says in core GDAL readable dataset. It just creates overviews basically of it, and then the map proxy on demand is just reads the DEM data and creates mesh from them. So you can work with basically, yeah, it's common GIS formats for that.
Okay, thank you. If there is another one, or okay, thank you very much for the presentation. Enjoyed it particularly well. So next one is Thomas Cavan, also from Mayo, and he's going to present us Beyond Latin Glyphids, Advanced System for Rendering Text in 3D Maps.